Okay, so solving systems of equations by substitution. So Friday we did solving by graphing. Solving by substitution does the same thing. We're still going to find where the lines intersect. But instead of doing it on the calculator and getting them both into slope-intercept form, we're going to find a different method. So what I'm going to do is I'm going to do an example problem with you guys, and then we're going to come up with the steps along the way as we go. All right, so our first one is going to be negative 4x plus y equals 6 and negative 5x minus y equals 21. Negative 4x plus y equals 6, negative 5x minus y equals 21. So in our previous method, what would we have to do with both of these equations before we could graph them? Yeah, they'd have to get into slope-intercept form. Now, this equation, or these two equations, I'll tell you right now, I'd probably use a different method for, again, the one we're going to do tomorrow. To be frank, this is as tough as substitution is going to get, so I figured I'd just show you this right out the gate, and then everything else that we'll do today will be pretty easy from there. So if we're going to substitute, I need to get something by itself, so that way I can actually do substitution. If you look at your variables, you really have four options. You could get the x by itself here, you could get the y by itself, or you could get this x or this y by itself. Which of those four variable options is closest to being isolated already?
Y.
Yeah, the y. So that's going to be my step one. I'm going to do steps over here. So step one, which equation should we isolate? Sometimes you're already going to have one by itself, so you don't actually have to do work to isolate it. That's when substitution's pretty cool. But in this case, we're going to go ahead and isolate this y value, because it already has a positive 1 in front of it, which means I won't have extra steps. So step one is identify which one you want to isolate. Step two is actually going to be solving so that we can isolate one variable. Now it doesn't matter if you isolate an x or isolate a y, both will get the job done. Do whatever is going to be the easiest. So for step two, I'm going to take our original equation, negative 4x plus y equals 6, and what's the only step that I need to do to get y alone?
Add 4x.
Perfect. So plus 4x on both sides. Alright, my variable is isolated. It's not the prettiest because, right, I still have an x involved, but this is going to allow us to effectively use the substitution method, which is going to be our step 3. Substitute into other equation. Substitute into other equation. Right there. So if you look at the other equation, I've got negative 5x minus y equals 21. Which variable did I just isolate on the first one?
Y.
So what that means is I'm going to go to the y on the new one, I'm going to take it out, and what am I going to put in its place? 6 plus 4x. Because if y is equal to 6 plus 4x, that means anywhere I see a y, I can take it out, and I can put a 6 plus 4x in its place. So for step 3, I'm going to write down our second equation, which was negative 5x minus, now instead of y, I'm going to put parentheses. And what did we say was going to go there?
6 plus 4x.
Yeah, 6 plus 4x. So now take a minute, go ahead and solve and get x by itself. This is going to be the first half of our solution. All right, make sure you guys get that negative distributed. What's going to happen here? Yeah, CLT, combine like terms. And then last two steps, adding the 6 and dividing the negative 9. So what this tells me is if I were to graph my two original equations, their point of intersection would happen at where x is negative 3.
It's 21.
Oh, what?
It's 21.
No, right here's good.
Oh.
Add 6. So 21 plus 6 gives us the 27. Hey, sometimes I do math wrong. It's cool. All right. So what are we missing now? What do we have to go find? Yeah, we still need the y value. So for our last step, we're going to go ahead and check, and we're going to put this negative 3 into both equations to just verify that our y values are the same, and that will confirm where our intersection is happening. So go ahead and take a minute to do that. Write down both original equations with that negative 3 in your x value, and then we'll see if all our stuff matches. Alright, did you guys get a y equals negative 6 for the first one? Okay, perfect. So then what would be our solution? It's a coordinate, remember? Negative 3, negative 6, good. So you could, if you wanted, check this by graphing. You could get y by itself for both, get it into slope-intercept form, y equals mx plus b, graph it, find your intersection, and it should be this exact same coordinate. But this would be the alternative method in using substitution.